Okay, so before we see the example of case study, Python code and the output interpretation of Gen AI, I thought let's spend some more time on Gen AI. In the earlier session, I've given brief at a high level, right? So let's understand this because this is very important. Gen AI and agentic AI understanding is very important, right? So executing is simple, but understanding Gen AI, understanding the business problem and correcting both is crucial, right? So to simply, to start with, what we have seen so far is a traditional AI. So simple traditional AI, this helps in prediction, wherein Gen AI, it helps in generating or creation, right? Generating the content. For example, the examples on traditional AI, we have seen that, will customer churn? Is this review is positive or negative? So these sort of example, is this an image of a shoe or not? The CNN example, right? So Gen AI does something different. It creates text, right? It creates images, it creates audio, it creates a video, and it also helps in coding, right? So from patterns, it learned in data, right? So think of a an author, a book author. So when an author writes a new paragraph, they are not copying a book, right? They are generating new content based on everything they have learned before. A simple example. Gen AI also works similarly. Suppose if you are starting a book, right? New book or a movie. So what you do, this new paragraph, you are not directly copying from older books. Maybe part of it may be related to this one, but you try to create something new. That's the way it's called as creativity. Authors, lyric writers, story writers, right? So Gen AI also works similarly, right? So this is the first part. The second part, the next word, how this happens, right? So when Gen AI predicts next word prediction, right? This is actually the sequence is different. The text sequence that we discussed in LSTM, forecasting, we discussed on sequence words, predicting the next word also we discussed at a high level, right? Most people think ChatGPT understands everything like humans, right? Actually, a Gen AI does something much simpler. It predicts the next most likely word, next most likely. Okay. Suppose if I say that I love drinking hot, hot. So you mentioned hot. So it will fill either it is coffee, beverages, or tea, right? Or chocolate or something. So model assigns the probabilities. Okay, say coffee 65%, beverages like 20%, tea is some the remaining 20%, something like this. Then choose one. I love drinking hot coffee. So then it predicts the next word again, right? In every, something like this, in every, during a meeting or during my tea break, whatever it is. One word at a time, thousands of times, just think, right? So every article, every email, every story, product description, and even code generated by ChatGPT starts with a repeated next word prediction logic. Simple. Okay. So how does the model, learn? If I let's take Shopsphere example, right? We have millions of product descriptions. Okay, so I have like millions of products, and we have millions of product descriptions. So let's say running shoes, right? And then something like maybe it says that okay, running shoes, and I'll give like mesh design, some mesh design, breathable mesh design. Right? Breathable mesh design is actually the air gets flow inside the shoe, right? So breathable mesh design, and then anti-slip. So you're just giving some features of your shoe. So the model see these patterns repeatedly. So there is a trillions of words got trained here for the model, ChatGPT or Claude or whatever it is. So it actually sees these patterns repeatedly. Okay. So then it learns, okay, running shoes, breathable mesh, and anti-slip, not so. So not because someone programmed these rules, just by learning different combination of words, different stories, different articles, right? Simple, if I put a simple example, a child learns language by hearing thousands of conversations, right? So during 8, 9 month, mom, dad, start, repeatedly making child to pronounce. So hearing thousands of conversation, child learns. Nobody explicitly teaches like every sentence. They only teach the words. So the child gradually learn patterns. LLMs, large language models, also learn similarly. The difference is scale. A child example, it starts with very slow or low, but wherein here it is a massive amount of words got trained. Trillions, maybe I could say. So trillions of words got trained and billions of parameters, right? So that is actually how LLMs works. Then the math. What is the math intuition involved here in this LLMs, right? So let's simplify the math dramatically, okay? For example, if I say the customer loves maybe like product or whatever, this product. The customer loves this product. Machine cannot understand this one, right? So first we have to convert these words to numbers, just like in NLP, how we discussed, right? So numbers. So there is this concept called embeddings. In a layman language, embeddings is nothing but embeddings is nothing but a vector form of text. That's it. Think of a vector as a coordinate in a giant language map. So you have a giant language map. You have billions of millions of words here. Each word is represented with one number vector. For example, if I say, let's say queen, king, right? Some just example, shoes, laptop, and this is 0.2, 0.1, okay, and 0.5. Maybe some other combination of words you can put it over here, and the relationship between these two is translated in a number format. Similarly, some numbers. So real vectors, like so many dimensions, of thousands of dimensions, like 860. Let's say there is a sequence actually 768, 1536, or 3072, like that dimensions. Okay, imagine plotting every word in the world on a giant map like this. Every word in the world, I'm saying. Words with similar meaning like live close to each other. Okay, for example, king and queen, right? And dog and puppy, right? Doctor and hospital. So machine can easily relate. Okay, what is the next word? Right? Why this embeddings matters is basically, we know, right? It doesn't understand English, so positions in a giant semantic map. Semantic map, we call it as giant semantic map. Hope you're understanding this one. This is very important. Otherwise, you won't able to execute on your own if you want to, right? So there is a giant map, word by word, relationship or semantic meanings got mapped, and that mapping is done through a number. That's embedding basically, right? So that embedding can be leveraged when you prompt something to extract the relevant information, right? So suppose imagine you are sitting in a noisy restaurant, right? Many people are talking. Your friend says your name. Immediately your brain focuses, right? That is what we call as attention. So actually here in Gen AI, attention is one important thing. What actually the attention? The biggest breakthrough in Gen AI is attention, right? I'll give a simple example. Let me clear this up. Okay, so the animal, let's say I'll give you an example here. The animal. So as I said, right, if you understand this attention logic, right, how actually this Gen AI LLMs work, it's easy for you to understand the remaining math part, right? The animal didn't cross the street. The animal didn't cross the street because it was too tired. this is one sentence here. Okay. So what does it refer to? This is attention actually. The animal doesn't cross the road. The moment you say because it, immediately goes to the attention, the animal, right? Humans, we know instantly, but how model will understand this one is this attention analogy. Okay. So attention asks basically which previous words are most important right now to this. Okay. So that is actually the attention analogy basically involved in LLMs so that machine can understand what actually this means. Then the next part is transformer architecture. At a high level, we discussed in our earlier session also. So what is this transformer architecture is? So again, attention became so powerful that researchers built a new architecture on this one, right? This is transformer architecture after attention. So before transformers, we have like RNN, LSTM, right? So when after transformers, we have GPT, Claude, Gemini, all these things. So transformer as a scanning the entire page at once and much faster and much smarter, right? So this is a transformer architecture on top of your attention to understand the semantics and get something meaningful as an output, right? So then once you have your, the GenAI thing, right? So existing model, GPT, the training is where what people spend a lot of money on this part. Okay. The model reads enormous amounts of data, right? Like websites, books, all websites, all books. Suppose if you ask something, sometimes it says that I'm not trained on that one. That means what? That model was not trained or read the respective content. So in the world, whatever books are there, books digitalized, okay, digitalized, then research papers and websites, right? Documents, publications, then conversations, everything gone through this model. The model have gone through all these things to understand, relate, and build this chained map, right? So just like, if I want to give an exam, right, what I'll do, I'll practice more and more. I'll try to complete all the relevant material, whatever I have available in my, my bag at my home, right? So similarly, so GenAI is basically gone through the as possible as trillions of parameters, billions of parameters, trillions of information, words, documents, everything. Right. So this is how the model got built on GenAI based like GPTs and all. Then how do you infer basically? The inference, this is the tricky part, right? After training the model enters the inference part. Inference is simply answering the question. So you understand, you go through the entire stuff, keep it in our memory, then infer something based on the prompt. Suppose if I say, hey, can you write a product description? So it will say whatever available information, whatever basic that you have given in your prompt, right? So that is at a high level, the math intuition. So the math is basically attention, transformer architecture, like, where the model understand what is this semantic meaning based on the trillions of words got trained. Then it creates that repository, keep it with the model, then start inferring based on the prompt. Okay. So we have like foundation models like, GPT, right? Claude, Gemini, Llama, DeepSeek, all these things, right? So, and also to if you want to leverage these models to answer your business question, like I have 10 documents of my internal organization, read all these 10 and help me if I ask a question from these 10 documents, right? So for that, you have to use embedding models to understand the user prompt to the base GPT model and then get extracted this output and give it back to the customer. So this is basically, to be honest, right, to convert your text into vectors. There are some embedding, already developed embedding models. You simply use those models to translate your prompt, what user is prompting, and get response from your master data set of GPT, then respond back to the consumer. Simple, as simple as that. Vector database. So if you want to, extract something relevant information related to an industry, finance, banking, pharma, etc., Pinecone, Viviate, Chroma, there are some vector databases. This is a long-term memory. Okay. So based on your chain map, it is a long-term embeddings were created. Again, same, a word, and word, semantic meaning, vector form. So machine will understand. Then RAG we discussed, right? So agents we discussed, I'll show you about example. And model context protocol also we discussed. These are all different layers on top of your standard architecture of transformations, right? So to conclude, it starts with the data, then convert them into embeddings, then use the vector database, translate that whatever prompt that user has given through the vector database, and then apply LLM, extract the information, could be through RAG if required for customization model, could be through tools or APIs, then give the output. Then you have to take the business action based on the output, right? For example, simple example in traditional AI Shopspeare, we discussed predict customer churn. The output is yes or no. Wherein generative AI, basically, if I say generate product description and if I put a product image, it will give new content like description, right? So that is about generative AI at a high level, the math intuition. So this looks magical from outside, but underneath it's a beautifully engineered system. Okay, words become vectors. Attention finds the important context. Transformers learn the patterns. The model predicts the next word. It repeats thousands and thousands of times. Okay, from simple mechanism to ability to predict or generate content. Right. So understanding this journey in the foundation is actually very I know it's a bit tricky, but I hope you got base understanding. You keep on practicing more and more examples. There's so many practical questions available in Kaggle you can practice, and I'll put more content as and when I see nice examples. Right? So let's see the Python code and let's see output, how to read the output. I'll give the business context of hands-on stuff of Gen AI example. Okay. So I just briefed, high-level math intuition behind generative AI models, right? LLMs. Okay. So again, I just refresh quickly. Think like this. So generative AI, okay, you don't need to build another chat GPT. Someone has already built, they trained, they made the machine learn the documents, words, I mean, research papers, websites, everything, and store the embeddings like a kind of a vector database, the semantic meaning of word to word and the relation and everything. You just need to use that semantic meaning and extract whatever information you need and create whatever content you need. Okay, there are like more than 120 models exist right now based on the existing GPTs. Everyone is not building GPTs from the scratch. They're leveraging the existing GPTs, right? Could be Llama model, Claude AI, or ChatGPT, OpenAI, ChatGPT. So these models they're leveraging and they're building on customizing on top of that for their business need. Okay, a simple example because this generative AI needs some tokens to procure. Why? So to make it more simple, right? So for example, as I said, right? So this is the master data set. Okay, in layman language, the giant map that we discussed, right? So the websites, okay, the research articles, the publications, everything is right, and some relationship between those billions of parameters has been defined in the giant map in some number format, vector format or embeddings. Okay, so I want to build something for my organization. This is Shopspeare. So I need to enter some inputs and ask my GPT to build product description, right? So every time when I prompt something, when user prompts something, this has to trigger the giant map, the master database like GPT or Claude, right, etc. So understand, bring the response through that vector, whatever language is acceptable between the machines, my internal through an API call. Okay, application protocol interface API call. That is basically that API helps to talk between two different interfaces on the web, right? So get that information and give prompt response to the user here. So for this, every time when you are calling something based on the token is nothing but one word. One word is one token. Based on the volume of the token, these guys charge you. It's not free. There is a limitation. Like always, if you see a free version of ChatGPT versus a premium version, you see the response difference. Okay, try it. But for your organization, definitely, if you are building something application and if you want to use this API call, you have to pay some amount per token. So I think 1 million tokens is $1 or something, 50 cents or some cost is there in both ChatGPT and Claudia, right? So that's the reason I'm giving very basic examples using Gemini basic model. Okay, so you can try. There are more than 100 models. It's like this is one model, right? This is model trained on billions of parameters. So whenever you prompt something, the text passed and then transform to the vector language, get the response and give as a response to you. That is how ChatGPT works, right? So please install this Gemini generative AI library in Python before you run, right? Then what I'm saying is that, okay, after running this one, take the generative AI library and configure API key. This API key, how to get API key? Go to aistudio.google.com. Then there is API key. So just create a API key, right? So there is a, this is already I've created. So I'll show you, delete this key. There will be a limit. The moment you create the API key, and later if you see this is API key, right? Just click it. Oh, yeah, sorry. Here it is. Create API key. So just give name. Suppose if you are building some project, you can give that name and create that API key. So that's it. So it gives that API key and you can leverage. I'll delete this one. Right? So like that. And again, if you see here, there is a setup billing option, billing tier. Based on the tokens, it will stop. It won't work. It tells that, hey, you utilized the quota. You have to pay if you want to bring more tokens response. Right? So that is how you can actually get. This is the API, sorry, aistudio.google.com API keys. If you just Google it, the page, you can create the API key. No, so I've created the API key and I wanted to see what type of models exist right now. See, this is one model, this is one model, deep research. There's so many models. Based on the subscription, it allows you to use this model. Right now, I'm using this model and you please replace your API key here, both the places. Okay, so this is the API key. You copy there and put it here. So I just created the API here. There is an option to copy that. So copy and put it there. Now what I'm doing is very basic example. Again, I'll explain here. If, uh, this is Gemini. I'm using Gemini model, right? So Gemini 2.5 Flash. This is the model name. What they have done, they created a giant mapping of word to word, and this all the information, whatever information that they trained, this model got trained. All this information is here in a vector form, vector database form, in or maybe in a layman language, embeddings. Embedding is nothing but word converted into a number through a vector database. These are all embeddings. Now, these embeddings, there is a number associated with each of these giant map. So when I prompt something, it will go and bring the relevant information and generate the content, text or whatever it is actually required. So you no need to build a chat GPT again. You can leverage the existing GPT model and make your work done. That's it. So how to safeguard my data, whatever I'm prompting, and if I want to put some customization, that means use this semantic meaning, but take my 100 documents of my internal pharma company related document, for example, or banking documents, then do help in responding something. Here comes the RAG system, retrieval augmented relation. I thought of giving an example, but it's I mean a simple Jupyter, it is not possible. I think I have to bring API keys and all. So yeah, you can practice. Maybe I'll try to create a separate course on this uh, generative AI and agentic AI in-depth examples. Okay, so many advancements are coming up soon. So let's see. I'll try to come up with a nice course on these two as well. Right. So this is how the model works and help you to build something. So what I'm trying to do here is simple. I'm using that model and I'm giving a prompt saying that write a product description for product name is so and so, active run, price is so and so, features, these are the features. Keep it under 100 words. That's it. So I'm using the model that is retrieved here from the generative AI library. Right? Simply it is giving unleash your potential, blah 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 blah. This is the output. You can type in ChatGPT also, but the same example, if you want to make it for your 10,000 products, you can simply create this as an application. Just put up, whatever application you have, like a web based or anything, you can put this sort of simple code. Okay, it gives randomly, it will pick the name and brief about that and simply give the uh, description. So Amazon will publish in their website. Sorry, my apologies. It's not Amazon, it's Shopspeare, our fictional e-commerce company. As it's more familiar Amazon every time it is getting, but yeah, it's a Shopspeare. So they will publish on their website, right? So that is one example. Similarly, another one is, so I'm just giving one more example here, like delivery. So this is delivery was late, but product quality is good. There are some reviews. Okay, so these reviews I'm using the same model again, generate content model from generative AI library of Python, right? It's saying that, okay, take these of what we call reviews and just generate the sentiment, top positive, top negative. Okay, so these are the four examples. What model is doing here? Simply, this is overall sentiment is positive, the first one. Delivery was late, but product quality is good. So it read that statement. After reading it, it is giving the summary. This is what actually my ask was. Okay, this is another example. You can create an application so that every review gets through this application and give a summary. The overall sentiment is positive, primarily driven by the strong performance and value of the product itself, but negative concerning delivery experience. Similar, the second one is excellent value for money. So product quality, functionality, value for money, like that. So you are trying to get use of the existing model and generating something. Okay, basically this overall sentiment you can take it as directly positive or negative neutral thing and build a classification algorithm, right? So a generative AI is a bit advanced. It is trained on billions of parameters and it's a language model, large language model. I'm sorry. So you can leverage this to beyond NLP, create some text, post videos and all. Okay, very very basic examples, layman, I could say layman examples, not a AI expert kind of examples. The reason that my objective of this fundamental is it's a foundation. If you understand this foundation, then later definitely you will see more courses, in-depth advanced stuff is coming up soon. So I hope the way I explain helps you to get that strong foundation. Okay, let's move.